All right, so number 7, Python Programming, Chapter 2, second edition, page 54. As an alternative to APR, the interest accrued on an account is often described in terms of a nominal rate and the number of compounding periods. For example, if the interest rate is 3% and the interest is compounded quarterly, the account actually earns 3/4% interest every 3 months. Modify the future_val.py program, the future_value.py program, to use this method of entering the interest rate. The program should prompt the user for the yearly rate, which will be called the variable rate, and the number of times that the interest is compounded each year. The variable will be called periods. To compute the value in 10 years, the program will loop 10 times the variable periods times and accrue rate/period interest on each iteration. Okay, so I found this online. You could do a search, compound interest formula. This is dpal.edu. And then I looked back. So here's our FUTVAL, FUTVAL program. So let's call this future value 2. And now we're going to save this as future value 2. With compounding periods factored in. So let's put here, okay. The future have multiple year investment. Future investment in principal. So this is a little bit different. So this is going to be the principal amount. This is actually not going to be so let's see. So let's dump this. This program calculates with an initial principal amount. Entered. Okay. So then we'll just call this P. So we're just going to call, this is going to be our initial principal. And let's call this R. To the annual interest rate as a decimal. Help the user a bit. So let's call this float. Let's call this float. Let's call this int. Let's call this t for time. And then n enter the number of times the interest is compounded per year. So that's going to be our n. So it's exactly the same way it's written out. And then that's from MoneyChimp. So let's use this. Okay, so this will be a little bit different. So let's do A equals. See, now that we've called those exactly the same things, the same names, it looks easier to do this. I know generally, I've been told it's generally smarter and better to put, names like principal or rate or time, or number of years, or num years. But just for the purposes of this, it's a short program. And, just for this specific exercise, I don't know what the prof would do. I don't know if we get, if I would get marked down on this, but it's easier. It looks easier as far as right now. So we're going to do P times 1 plus R divided by N. And then this is going to be to the N times T. Now, if we wanted to, we could change this to principal. Change this to principal. This rate. Years. And then compound. CP. So that's going to be years. And compounded, essentially. All right, so let me fix that like that. So the value in string A string. All right. So let's use this exact example as we do our test. Okay. So we'll do probably a bunch of examples, but for the purposes of this video, we can just do one example. All right, so this is future value 2. Okay, so the initial principal 1500 decimal 0.043. Number of years is going to be 6. That's for quarterly. 1780. This number's a little bit off. Let's check it out. Put everything in right. 1500.043. Yep. 6. Is going to be our total number of years to compound. And the number of times compounded per year is going to be 4. So let's fix it. Let's make sure this is correct. Okay. So principal times 1 plus rate slash years. And nope, it's not years. You guys probably caught this. Slash n, not g. Let's save that. Let's go back here. Now we will. Let's go here and then open. Right, let's see if this works. Let's see if we change this. Number of times compounded, which is n, not t. Right. So exactly the same numbers. So let's scroll this up so we can see it. All right, so 1500.043 as a decimal. Total number of years to compound is going to be 6 years. And then it's compounded quarterly. So every quarter, a quarter happens every 3 months. That's 4 times a year. 4 times 3 is 12 months. And then we got 1938. Boom, 0.84. So there it is. There's our program for number 7. We would obviously try this, 5 or 10 or 12 times, different numbers to check it out. But yeah, this looks pretty decent. We'd obviously add some comments as well, but this is the overall gist of the program. We do have some comments here, but maybe we would add potentially more. Actually, this is a lot of comments for this short program. But yeah, hopefully that helps. Number 7, page 54 on Chapter 2, Writing Simple Programs. Thank you very much.